All right, guys, so we're continuing on with chapter 4, 4.3. Matrices, multiplying matrices is what we're going to talk about today. Now, you can multiply two matrices together, A and B, if and only if the number of columns in A is equal to the number of rows in B when you multiply the two matrices together. The resulting matrice, if we can multiply them, will be M times X. So, well, let's just look at this a little bit closer. So the dimensions of matrix A are M by R, and the dimensions of matrix B are R by T. Since the columns of the first match the rows of the second, these match up. It means the new dimensions are going to be the rows of the first by columns of the second. And that's how we get the new matrix. And that's it. So if the columns of the first match the rows of the second, then the new dimensions will be the columns or rows of the first and columns of the second. So we look at this first one here. So this example here. So what we need to say is does this here. So let me get a arrow. Do these two here match? Because if the columns of the first matches the rows of the second, then we can say the two matrices are multiplied. We can multiply the two together. We can do A times B. Well, yes, we have 4 and 4. So our new dimensions for this are going to be our 3 and 2. So the new dimensions of this matrix, if we do A times B, will be 3 by 2. And that's it. That's all we have to do for this here. We're not actually multiplying anything. We're just determining whether or not we can multiply them together. So I can do A times B. And I get this here. Now, could I do B times A? Well, B times A would be a little bit different because here, because our columns of the first would not quite match the rows of the second. Because if I do B times A, columns of the first does not match the rows of the second. So I couldn't do B times A, but I can do A times B. So we can do it that way. Now let's look at the second one here. A times B. Well, columns of the first does not match rows of the second. So I cannot do A times B for this next one. A times B does not work. Okay, well, let's try the other way. Let's do B times A. Columns of the first times rows of the second. Well, that doesn't work. So I cannot do these at all because columns of the first and rows of the second do not match up. So we can't multiply these. So let's look at two more. So look at this here, A times B. Columns of the first, does it match up with rows of the second? Well, yes. So we can multiply these, and our new dimensions are going to be 4 by 2. So the new dimensions for this here are 4 by 2. Because columns of the first match rows of the second, so we can multiply these, and it's going to be 4 by 2. And that's it. That's all we have to do for this here. Now looking at the next one, so again, A times B, columns of the first, rows of the second. Well, these don't match, so that means I can't multiply them. And we're done. Now we could try it the other direction. Let's say B times A. Let's switch it. So if I said B was first, if I said this one here was first, so columns of the first, rows of the second. Well, those don't match either, so they don't multiply either way. And that's it. That's all we have to do. For that part there, that's really all we've done so far is really been able to determine whether or not can I multiply two matrices together. That's really essential before we even start anything else. So the columns of the first have to match rows of the second. So we look at this here. When we multiply two matrices together, what we do is something I call over down. So when we multiply over and down. And then we go over and down. Over, down, over, down. I'll choose a different color. Over, down. So when I multiply these here, what's going to happen first? When I multiply, I'll use type. So we'll multiply over and down, and the elements in the nth row and we multiply corresponding elements in rows M and N and add their product. So we'd go A and B, E and G, over, down. So it'd be AE plus BG. And that would be the first element. So in the top top left would be this element here. So ABEG. So that'd be our first one. Our next one would be ABFH. AF plus BH. And that would be the first row. Would be that there. Now we would move down to the second row and go CD over down. So this here would be C times E plus D times G. And we do it again. Over, down. So what we would get is CF plus DH. And that would be our matrix after we multiplied them together. And that's it. That's all we'd have to do for this here. If we multiply, we do this over, down, over, down. And we do it for however big the matrix is, as long as the columns of the first match the rows of the second. Then we can be able to multiply them. So we're going to look at this first one here. So the first thing we're going to do is we're going to copy them down. We want to do x times y. So x goes first, y goes second. Now I want to check and see. So this here is x is a 2 by 2. And it's being multiplied by a 2 by 2. Columns of the first does match the rows of the second, so that means we can multiply it. And our new matrix C is going to be a 2 by 2. And so that kind of gives us an idea of what we're looking for. So these two, so since the rows of the first match the columns of the second, we can multiply these together. And the new dimensions is going to be a 2 by 2. So that gives us an idea of what we're looking for. Okay, now we're going to go on and start multiplying. Now when we multiply, again, we go over, down. So in the first spot of this matrix, what we're going to have is 6 times negative 5. First element here, first element. So those two multiply together. And we add to it negative 3 times 3. So this gives us our first spot. So kind of in a 2 by 2, the upper left, this is our first element. Now we're going to do this again. We're going to go over, down to get our second element in the top row. And to get that, we're going to start with 6 times negative 4. And we're going to add to it negative 3 times 3. And we get this here. Okay, so we finished the top row of the first, multiplying through. Now we're going to move on to the bottom row. So we're going to go over and down, over and down. So what we're going to have is negative 10 times negative 5 first, plus Then we'll have our negative 2 times 3. Scoot some of the stuff over. Okay, and that brings us to the last part. Over and down. So we'll start off with negative 10 times negative 4 plus negative 2 times 3. And that's it. So, well, not completely, but that's multiplied out. So we have it multiplied out. Over, down, over, down. Going over, down, over, down, over, down, over, and down to get our matrix. Now what we have to do next is we need to simplify this. So we can't just leave it in this form. We have to do some multiplication and simplification. Well, the first thing we can do is 6 times negative 5, which would be negative 30. And negative 3 times 3 would be minus 9. Now, if you really wanted to, I will tell you this here, really at this point here, we could have plugged this whole thing, each one of these as a whole into the calculator and gotten each number. We could have done that, and that would have given us our answer a little bit quicker. So I'll keep doing these stepped out. So 6 times negative 4 would be negative 24. And negative 3 times 3 would be negative 9 again. So 24 minus 9. Our next one, negative 10 times negative 5 would be 50, positive 50. And negative 2 times 3 would be negative 6. So we'd have 50 minus 6. And lastly, negative 10 times negative 4 would be 40. Plus negative 2 times 3 would be negative 6. Okay, so we have this here. Now the last thing we need to do is we just need to simplify this one last time. We need to combine these terms, and then we're done. So we do that, negative 30 minus 9 would be negative 39. Negative 24 minus 9 would be negative 33. 50 minus 6 would be 44. And lastly, 40 minus 6 would be 34. And that's all we have to do for this here. And we're finished multiplying these together. We're done. So when we multiplied these two matrices together, x and y, when we multiplied them together, we ended up getting a 2 by 2 matrix, 2 rows and 2 columns, 2 rows, 2 columns, a 2 by 2, and it was negative 39, negative 33, 44, and 34. And that's it. We're done. We're done with this one here. All right, so we're going to do another one here. All right, so when we look at this here, again, let's check to see if we can multiply these together. Now, the dimensions of our first matrix here is a 2 by 3. So it's a 2 by 3. And our second matrix that we're multiplying is a 3 by 2. So we have a 2 by 3 being multiplied by a 3 by 2. So we're looking at a 2 by 3 being multiplied by a 3 by 2. And we want to see, will these two, can we multiply them together? Can we take their product? So when we look at this here, so the columns of the first has to match the rows of the second. And for this one here, it does. So we can multiply these together. And our new matrix is going to be rows of the first by columns of the second. So our new matrix will actually be a 2 by 2. So even though we have these two big matrices, our new matrix is just going to be a 2 by 2. So we'll just have 4 elements. We'll have 4 numbers in the matrix when we're all done. Now when we multiply, again, it's going to be the exact same as what we did before. We're going to go over and down to get our first element. And we do that here, it's going to be a little bit bigger than last time because we do have a few more numbers, but we're going to still do the same thing. So it's going to be 1 times 2 plus. Our next number would be 3 and negative 2. So we'll do 3 times negative 2 plus negative 5 times 1. And that's our first element, over and down. And we multiply and add. Now we're going to do it again. We're going to go over and down. So we'll start off with 1 times 3 plus 3 times negative 8 plus negative 5 times 7. And that's it for the first row. We went over and down, then we went over and down, multiplying and adding those numbers together. Now we're going to go to the bottom row of the first. So we're going to go over and down. So we multiply here, it'd be 4 times 2 plus negative 2 times negative 2 plus 0 times 1. And that's it. That's all we have to do for the first part. Now the last part, the last set that we have to multiply together is going to be over. So this bottom row again, times our second column down. So our first one would be 4 times 3 plus negative 2 times negative 8 plus 0 times 7. And we're finished multiplying. So that's all we had to do to multiply these together. So we multiplied them, we went over, down, to get our first row. Then to get the rest of it, we went over, down, to get this row here. Now the last thing we need to do is we need to simplify these here. We need to simplify our numbers. So for the first one, I'm going to multiply each one of these individually. So you could do that, or you can do it in a calculator. You can go on and type this all in. So do 1 times 2 plus 3 times negative 2 plus negative 5 times 1. And the calculator will give you the answer. But if I did this individually, so 2 times 1 would be 2 plus, well, 1 times 2 is 2. 3 times negative 2 would be negative 6. And then negative 5 times 1 would be negative 5. So we'd have 2 minus 6 minus 5 for the first. So the next one would be 3 times 1, or 1 times 3, which would be 3. 3 times negative 8 would be negative 24. And negative 5 times 7 would be negative 35. Then we move down here, so 4 times 2 would give me 8. Negative 2 times negative 2 would give me plus 4. And 0 times 1 is just, well, plus 0. It's not really adding anything. Then our last set of numbers would be 4 times 3, which is 12. Negative 2 times 8 would be plus 16. And then 0 times 7 would be 0. Now we're almost done. Now we just need to combine these last terms. And once we combine those, then we are done. Well, 2 minus 6 minus 5. Well, 2 minus 6 is negative 4. Minus 5 would be negative 9. 3 minus 24 would be negative 21. Minus 35 would be negative 56. 8 plus 4 plus 0 is 12. And 12 plus 16 is 28, plus 0 is just going to be 28. And that's it. We're done with that there. So we multiplied, did our over, down, over, down, over, down, over, down, combined our terms, and simplified, and got this matrix here, a 2 by 2, which we knew we were going to get, negative 9, negative 56, 12, 28. And we're done. That's all we have to do for this one here. All right, so we're going to look at another one, this one here, and a few more of these here. And then we are going to be done for today because we're just doing multiplication. And we can do some addition, but we're going to be looking at mainly multiplication. So when we look at this here, h times g. We want to look at the product of h times g. Well, we just did the product of g times h, and when I did g times h, we got this here. So now we're going to flip it and do h times g. Well, h is this one over here, and it's a 3 by 2. So we're going to be multiplying a 3 by 2 by a 2 by 3. And we're going to see, and let's check and make sure that this works. So 2 rows of the, or columns, yeah, rows of the first and columns of the second. Okay, so they do match up. So that means we can multiply them. Now our new matrix here is going to be a 3 by 3. So our new matrix that we're going to be finding, the one that we're going to find, is going to be a 3 by 3. So we can multiply these. Now I went on and kind of took a picture and copied them down here. So we have these down here. And we are able to multiply them together because we checked and saw that the columns of the first matched rows of the second, so it does work. And our new matrix is going to be a 3 by 3. So let's go on and start. So we would go over 2, 3, down. So our first set of numbers that we're going to have is going to be 2 times 1 plus 3 times 4. And we're done with the first. So let's move on to the next. So it'd be 2 times 3, and then 3 and negative 2. So we would multiply these. So our next would be 2 times 3 plus 3 times negative 2. Now we still have one more with this top row, over and down. So we're going to do this one here. So this would be 2 times negative 5 plus 3 times 0. So we're done with the first row. Now we're going to move on to the second row. So we're going to go over and down again. So we're going to repeat this process. So we're going to end up repeating this process 3 times because I have 3 rows in the first. So it'd be negative 2 times 1 plus negative 8 times 4. Now we're going to do it again. So negative 2 and negative 8, and we multiply it by the middle one, this 3, 2. So this here would be negative 2 times 3 plus negative 8 times negative 2. And lastly, pick a different color. We're going to go over and down. So when we look at this here, it'd be negative 2 times negative 5 plus negative 8 times 0. And that gave us the second row, which means we're going to move on to the last set. So we're going to do 1 and 7, 1 and 4. So we're going to repeat it again, which would be 1 times 1 plus 7 times 4. Now we're going to move on and do 1 and 7, 3 and negative 2. So we're going to do the next set. So it'd be 1 times 3 plus 7 times negative 2. And that brings us to the last set, which will be our 1 and 7, negative 5 and 0. So we had 1 times negative 5 plus 7 times 0. So this here is it multiplied out. Now we still need to simplify these terms. So I'm going to expand the page a little bit. So once we simplify these terms, then we're done. Then we have it fully multiplied out. So at this point here, again, just like with any of the ones we've done previously, you could go on and type all this into each one of these into the calculator to get it, or we can do it individually. So I'm going to do it individually, as in 2 times 1 gives us 2, and 3 times 4 gives us 12, so we'd have 2 plus 12 in the first spot here. And then we would, in the second one, 2 times 3 would give me 6. And 3 times negative 2 would be negative 6. So we'd have 6 minus 6. And the last one in the top row would be 2 times negative 5, which would be negative 10. Plus 3 times 0 is 0. Now the next one, negative 2 times 1 would be negative 2. Negative 8 times 4 would be negative 32. So we finish that one there. We move on to this one here. Well, negative 2 times 3 would be negative 6. And negative 8 times negative 2 would be plus 16. Line that up a little bit. And lastly, so negative 2 times negative 5 would be 10. Plus negative 8 times 0 would be 0. Last row, 1 times 1 will be 1. 7 times 4 would be plus 28. 1 times 3 is 3. 7 times negative 2 would be negative 14. And lastly, 1 times negative 5 would be negative 5. Plus 7 times 0 is 0. So we're multiplying and simplifying. And lastly, we just need to simplify these here, add these or subtract these from each other, and then we are officially done. Well, 12 plus 2 is 14. 6 minus 6 is 0. And negative 10 plus 0 is negative 10. And that's our top row. Now the next row would be negative 2 minus 32, which would be negative 34. Negative 6 plus 16 would be 10. And 10 plus 0 would give me 10. And lastly, 1 plus 28 would be 29. 3 minus 14 would be negative 11. And then negative 5 plus 0 is going to be negative 5. And that's it. I'll need to put my 2 brackets on either side, and this here is our answer. This here is the matrix for G times, or H times G. So H times G gave us this here. Now, I want to recall something, because G times H, I think, and it is a little bit different. So I copied G times H from the other page, what we just did previously. And are these the same? Is H times G the same as G times H? Well, no. One of them gave us a 3 by 3, and the other gave us a 2 by 2. So G times H is not equal to H times G. Because as we can see here, that doesn't work. Now, with most multiplications, with most other multiplications, it will work. So 2 times 3 is going to be the same as 3 times 2. Multiplication is commutative. Order doesn't matter normally, but with matrices, order matters. Order does matter when we're multiplying matrices. So here we can't just flip it. The order does matter. And that's why we did these two here, to show that H times G and G times H, just because I flip them, does not mean I will get the same matrix. Now it does work with addition, it just does not work with multiplication. And if you're wondering, yes, we could have plugged these into the calculator. The calculator, the TI-84 graphing calculator, will do these here. And that's it for this here. Now, we can do addition, subtraction. So you can do this here. So I could do k plus l and then multiply it by j. And it will work. It will work that the distributive property does work for this here. That j times parentheses h plus, or a parentheses k plus l is going to equal, it will work out that it's equal to jk plus jl. It does work out. And it also works out that this one here, so the left and right distributive property do work. So these are the properties that do work, and I'm not going to go through and individually show them because I feel like y'all have gotten the hang of just kind of multiplication, and you are able to type these straight into the TI-84 graphing calculator to get your answer also. Now, associative property of matrices multiplication, A times B times C is equal to A times B times C. And if you notice, the order didn't change. A, B, C, A, B, C. So which two I decide to multiply first, I can do it in any order, but I cannot change the order. A, B, C, A, B, C. I can multiply through by a scalar. Scalars, it doesn't matter which one I do first, but I can only apply it to one matrix. I'm not going to apply it to both. I'm only going to apply it to one. And left and right distributive property. And that's it. So your homework for this assignment here is on page 204, problems 1 through 11 all. You can use a calculator if you want. You can use the TI-84 calculators if you want. And that is it for this lesson here.